Hello everyone. Welcome to this video where we're going to be talking about how to define foundation rebar, specifically within the pads of our foundation. So we've got a few different types of rebar that we're going to define, and we have three different types of foundations to use to explain this type of workflow for us. You will notice that when we define a foundation, even if we haven't specified any reinforcement, it's going to have within the rebar tab the display of the reinforcement already done for us. So in this example here, I've got a spread footing, I've got a kind of angled shape wall foundation, and I've got a mat foundation as well. And these all have reinforcement despite me not having defined it yet, and that's due to the fact that it will auto-generate rebar for us based off of the settings within this field in the design input window under auto-generated rebar container. So that's where that information is coming from. But let's just start off by looking at some of the different definitions of rebar that we have available to us. And I'm going to use the spread footing example, or isolated footing, as my starting point. So I can dive into this a little bit more by right-clicking on it and going to Define Pad Pile Cap. Another option as well, which gets us to the same spot, is to go to Define Menu, and I can go to Pads Pile Cap as well. And in this example, I said I was going to start with the spread footing, which is the first of the three pads that I see here. And this can be applied to different types of foundations. And I want to look at the different definition, or the different parameters that I can define rather, for this type of reinforcement. You'll see right away that I have a rendering from a plan view of the reinforcement that we have. And this is also showing me some of the dimensions and different properties related to the definition of this pad. And below that, we have information related to the rebar. So I can see here the first tab is showing me rebar. It's kind of a high-level definition of our reinforcement, where we have it separated into different columns. We have the top and bottom layers, how many top and bottom layers I have. I have a tab for patches, which we'll get into more later on. I also have a tab for strips, which we'll talk about shortly. And then a uniform demand force. So this actually goes a little bit into what I'm going to be talking about next with the different types of reinforcement. But the default type of reinforcement for a spread footing is a uniform reinforcement, meaning that we have essentially the same type of rebar and spacing in each direction throughout the entire size of the pad. So we can't actually vary it between X and Y directions and top and bottom layers, but it's meant to be consistent throughout the entire dimension. And what's going to happen is when we define reinforcement in our pads, we're going to have these strip integration lines generated as well. And these are used to calculate the demands. Basically, they integrate the shell element contours, and they can be configured to extract those demands in different ways. So they're given a width that's equivalent to the width of our rebar strip, and that width can be used to sample different results along the length, along that width as well. And so do we want to average the results across the width of our strip integration line, or do we want to look at the maximum result across the width? I generally like to use the average option, and it's more consistent with SRAM if you're using SRAM for comparison, so you should be able to easily compare between the two there. But you do have the option to choose either one. So I went on a bit of a tangent with the demand source, but I think that's worth exploring here first of all. Now I'm going to actually switch gears and look at the uniform tab, and reminding myself that I've specified that I have a top and bottom layer. These can all be user defined, so I could say I don't have a top layer, for example, but maybe I have a bottom layer or two bottom layers. We can enter these data points as much as or to be whatever we would like it to be. I'm now going to switch to the uniform tab though, and I can see how my uniform rebar is defined. So I have basically two rows in this spreadsheet, one for the pad top rebar layer and one for the bottom rebar layer. It's showing me the reinforcement in the X direction, so we can see this column is referring to the X direction and the Y direction. And the bar ID is the bar size that's being used, and then we have the bar count. We can also enter bar spacing, and the bar count will be back calculated to the closest bar count that would reflect with that bar spacing. So we can configure this in different layers. So if I wanted to go with a larger bar size in the bottom, for example, I can say I have a 20M bar, and here I might want to control, well, we'll notice a difference here graphically, but I might want to control the bar count. So maybe I want to go with a X bar count of 14 rather than 12, if I can type correctly. And you can see not only has our bar spacing changed, but the graphical representation of this has also changed. Now this maybe not so round number of bar spacing is used to actually calculate based off of the 14 bars we've had and the cover of our reinforcement and so on. This is what the actual bar spacing would be. If we want to actually enter a bar spacing instead, it will calculate the next closest bar count. So if I say I want a bar spacing of 150 millimeters, I can enter that here and it's going to calculate the bar count that would reflect that. The next tab over, we have the hook tab, which is going to allow us to control the hooks on our rebar. So here I can see, if I just maybe zoom in a little bit more, we can see that we do have hooks and we can control the radius of the hook and also specify it to be based off of the dimensions of the rebar or the pad itself, or just a user-defined length. Next to that, we have the extension tab, where we can control the extension relative to the bar diameter or the thickness of the pad again, or our own custom length. And then finally, next to that, we have the strips. So I'm going to switch back to my original top view here. And we can see here that we've got, well, maybe it's not so easy to tell. I'm going to turn off some of the information here. Let me just look at what I can turn off. So I'm going to turn off my uniform rebar. And I'm left with basically these blue squares or rectangles. And these represent the strips in my foundation that are automatically created, and they're centered on the pedestal that I've defined. So I have two strips, strip index 1 and 2. You'll notice that one of them is in the X direction, and it starts at 0 and it extends the whole width of the pad. And the other one is in the Y direction, and it is not extending the whole width of the pad, but it's extending basically a width of 2,500 millimeters to sample the response and the results of our foundation along that pedestal zone or that column zone. And once again, I have control over the demand source that I saw there. So here we can specify or change the width. We can add additional strips if we wanted to. So I could go back to the high level rebar tab and I can say I want 3 strips rather than 2, for example. I just type in the number I want. And then once we're satisfied with our strips, if we did want to add additional bars in a certain direction, for example, I could add those just in that specific strip area. So I could say here I've got a strip rebar that maybe has a definition that is a different bar size, for example, than what I have elsewhere. So in the x-axis, for example, I could say I have, I'll go with a strip spacing of 150 millimeters, and it's going to add those extra bars in there, and they're going to be working alongside the uniform bars that I have in my model. Going back to the rebar tab here, you'll notice that we actually have, not only do we have strips and the uniform bars that we talked about, but we also have the option to add patches, which I'll talk about more later on. So let me just cancel out of here and look closer now at our wall foundation. And the wall foundation is defined a little bit differently than the spread footing. We basically have these different segments of our wall that are collinear, and then we might have a different direction for the next segment. So to do this, we're not using uniform rebar. Now we're using patch rebar, which is a little bit different than strip rebar. And so if I just look at this data a little bit closer, I can right click and go to Define Pad Pile Cap. I select my foundation that I'm interested in. And you'll notice right away that it's showing me the patches. So if I go back to the rebar tab first, I can see that I don't actually have the ability to define or change the number of patches that I have, but I do have the ability to configure the patches a little bit differently. You'll also notice I don't have uniform rebar, which would be shown in blue on my screen. It's just the patch rebar that I have at the moment. So here I can go in and I can change the hook and extensions like I talked about earlier. But if I wanted to look at the patches, you can see that this information is actually all grayed out. So I don't actually have control over this, but I can configure the patch rebar. So within this patch, I'm basically controlling the reinforcement within this one rectangle effectively, and doing the same thing for patch number 2, just in this Y direction oriented rectangle. So I can modify what the bar size is at any location, or within any patch. I can change the bar counts there and make it to be whatever I wanted it to be, and it will be reflected in my capacity calculations. And just like before, what we saw is that we do have strip integration lines that are generated along those patches, just like they would be in strips, for example. And those will calculate the demands on our structure and compare them to the capacity along that strip or that patch. And the patch rebar, if there were other types of reinforcement involved, like uniform rebar or strip rebar, would work to resist the loads applied on that particular patch or strip or whatever it is that we're looking at. So the last foundation that we haven't really looked at closely is the mat foundation panel. And you can see here that I've got a mostly rectangular mat foundation with a little bit of an angled edge to it on the one side. And I've got 5 different pedestals. So right away we can kind of make out the strips that are created along the pedestal locations. And I'm just going to dive into this a little bit more. I'm not going to necessarily modify the existing strips, but I do want to explore them a little bit more. So if I go to the tab that allows me to define this information here, the rebar tab at the top, we can see that we have top and bottom layers of uniform rebar, which again I can control here. I can modify the bar sizes that I have available to me, the bar counts, and so on. We also have, as we see, 5 different strips. So I have one in this direction here, a second one in the Y direction, and then I have 3 in the X direction. And I don't currently have any patches. But let's look at our strips a little bit closer. You can see that we do actually have the ability to modify these locations and the directions and the widths and the demand sources. And of course the reinforcement that's being used in these. Right now I don't have any extra reinforcement, but if I wanted to, I could go ahead and define that. So let me just choose one strip as an example. Let me just go with the bottom rebar here on one of these strips, and I'm going to say here that I have 30 M bars, and I'm just going to go with a strip spacing of 120 millimeters. And you can see that it's added that to that foundation. And I can do the same thing maybe for one more, just to see if we can get a little bit of an interesting display going on. And again, I'm going to say the same bar count that I had before. You'll notice here that this one has a angled edge at the end, which is accounted for there. If we wanted to add additional strips to our foundation, we can do that as well. So I can click on the rebar tab again, and right now it's showing me 5 strips, but I want to add one more, so I'm going to click on 6 strips, let that take effect, and then go back to the strips tab. And you'll see here, maybe I just expand this because I do have quite a few strips. You can see here that I have the offset that I can define, the direction, and the width. So let me just go with the offset of, I'll say I'm going to use a value of 4,000 millimeters. I'm going to have it offset in the X direction, or the direction, sorry, is in the X direction. And then I'm going to specify a width of 2,000 millimeters. So you can see it's kind of landing between my 2 pedestals right here. Now I can specify the rebar in that area. As you've probably observed by now, I'm looking for strip index number 6, specify the type of rebar that I want and the bar count. And again, I'm just going to go with the 13 bars just to allow that to show up there. So if we wanted additional capacity for flexure, for example, in that location, that would be one easy way to do it. It extends the entire length of the strip or the pad in that direction. The last option that I want to just indicate here is the definition of custom patches. So I can go ahead and define that as well. I specify how many patches I want. I'm just going to say I want 1. And with the patches defined now, this is no longer 0. I have this tab that allows me to define the patch. So here I can specify my starting point of the patch. I'm going to say it's at 2,000 millimeters in the X. This is the minimum location, and 2,000 in the Y. And then for the X location and the maximum, I'm going to set this to be, I'll say this is 5,000 millimeters, and in the Y direction it's going to be 4,000. So now we can see this patch has been defined. It's actually kind of just ending at the top of the pedestal there. And we have the ability to control whether this is an orthogonal patch or an angular patch. If it was angular, we can specify, again, the width that's going to be defined as well. I'm just going to go with the orthogonal option. And now I just want to jump into the patch rebar. And the reason for this is that I can define, again, within a more concentrated area, the reinforcement that's being used. So let's say I'm going to use a slightly larger bar in the X. I'll do the same thing in the Y-axis. 35 M bars. And I'm going to say that we have 100 millimeter spacing for these. This may not be necessarily realistic, but again, just showing you how this can be set up. And the same thing in the Y-axis, 100 millimeter bar spacing. And now we have, along the bottom of our pad, some larger bars that are quite a tight spacing, contributing to the capacity in that location. Also, since we've defined this patch, it's going to create a strip integration line centered on that patch, extending just the length of that patch, unlike the strip that extends the entire length of the pad. So hopefully this gives you a bit more information about S Foundation's rebar definitions. And if you'd like more information on S Foundation, we have plenty of YouTube videos available. We also have a training course, and you're more than welcome to reach out to us if you have any questions.